Alright, so we are trying to find the cation anion radius ratio when the coordination number is 3, right? For a particular structure like that in ceramics, this is what we know. We know that we have the cation at the center, and then the neighboring anions are 3 that are in contact with it. This is not a perfect diagram, so you are just using this as an example. Okay. Looking at this closely, we can see that if we try joining the centers of the anions, we get something of this sort. Right? Get something of this sort, and then these are the centers, right? And then straightforward, this is what we can see. We can see that because these are, what's the name, these are what do you call it, circles that are in contact with each other, like they close contact with each other. The triangle that we get by joining their centers will be what do you call it, an equilateral triangle, right? Meaning that the centers, sorry, the sides are the same, right? If the sides are the same for equilateral, this should be in contact by is open. Let's take it that way. The sides are in contact, so then we can say equilateral, meaning that the angle here is 60. All the internal angles are 60, right? So we know here to be 60 degrees, right? But here's the key: is our interest is finding what the cation anion ratio, which is this RC over RA, right? We can't do this directly, but then we can use Pythagoras theorem to find this. This is what we do. Straightforward. We get to know that because we draw what do you call it, perpendicular line from this base here, right, to this center. A minute. From this base here to this center, right? This will give us a 90 degrees here, and then we draw a line from here to the center of this particular circle here, right? So this particular triangle, so the first triangle is what we get here, where we have the angle to be 60, an equilateral triangle, right? And then the second one, the smaller one that we are getting, we have here to be 90 degrees, right? And then looking at this one very well, we know the angles here are 60, 60, right? But then looking at this is very straight, like a what do you call it, vertical line to the center of this anion, right, sphere. So then here is what half of the whole angle, which is what 30. So here is what 30 degrees, right? Looking at this one again, we know from here to here, this side, let me use another color. We know from here to here, which forms this triangle, is this side, right? Right, and then which is the radius of the anion, right? And then again we have from here to somewhere here, which is the same radius of the anion, right? And then we have one final piece, which is just this side. So at this point we have two lines, two radiuses, right? And here, this is what we end up getting: the radius of the anion. Here's radius of anion, and this side is radius of cation, right? And then we have an angle of 30 on the inside here. Let me write this out clear. An angle of 30, right? 30 degrees. Then when we have this, here's where we can do what we want to find what we can do what we need to do to find this, right? Looking at this here, we can do Pythagoras. This is the adjacent, right? If we turn this triangle, this will be our adjacent. So we know, let's do this. We know cos, that's look at or something. Cos is adjacent of a hypotenuse, right? This is what we get. So then cos of this angle here, 30. Cos 30 degrees. Where's our adjacent? Our adjacent is this side, right? Because this is the angle we are using, and this will be a hypotenuse, right? So there's our adjacent, that will be RA, and the hypotenuse will be RA plus RC, right? We can manipulate this to get our RC over RA. That's what we can do. So now that's what we are doing. Let's see. Okay. So now we have this, right? And what are we trying to find? We're trying to find RC over RA, right? This is quite simple. We get cos 30 into bracket RA, right? And then plus cos 30 to bracket RC C, right? And all this is equal to what? RE, right? Our interest is RC over RE, so that's what we do. You end up getting when we bring the RE's on one side, let's see what we get. We get cos 30 RC. Let's take the RE's to the other side because we want this, right? So let's see. So we end up getting cos 30 RC, then we get what? RE minus cos 30 RE, right? Which is RE to bracket 1 minus what? Cos 30. Let me write this out. 30, right? So now clearly we can get our RC over RE. RC over RE gives us 1 minus cos 30 degrees, or no, cos 30 degrees, and that's what it gives us. Function that we have 1 minus cos 30 or cos 30, and this gives us, if you punch it right, you get something like this. Convert it to decimal and you get something of this sort, 0.15 approximately to 3 decimal place 1. This right here is the lower limit for the cation anion ratio when the coordination number is 3. Yeah, alright.